Hey guys, Miss James here, coming to you with week 2 practice problems. So this week with Miss Fu, you guys learned about word problems, how to write them about system of linear equations and inequalities. So let's get started. First things first, quick recap. Hopefully, and I always say this, you watched the video with Miss Fu first. It doesn't make sense to watch this video because I'm not going to be as detailed and thorough as Miss Fu was explaining it the first time. So it doesn't make sense to watch this unless you watched her video. So if you haven't, stop, go back and watch her video. All right. First thing that we want to do is highlight any important information in the problem that will help to write two equations or inequalities. By important information, all we mean by that is just what is the problem talking about, and what are we what information kind of leads us to that? Are there any keywords like at least, at most, in total? We're looking for those words to kind of guide us. Second thing, we're defining the variable. So every time we have these type of questions, we need variables, right? They're systems. There's always two variables in these type of questions that we're working on. So we have to define them. We can't just use X and Y and not let people know what we're talking about. So sometimes they give you the variable and they tell you what to use, but if they don't, you have to say, let X stand for this, let Y stand for that. Lastly, you need to figure out, you need to write the two equations or inequalities, and you can ask yourself, what does each inequality or equation even relate to? So let's do systems of linear equation word problems first. Here's our first question. Mo's farm sold a total of 165 apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds of peaches did she sell? So as Ms. Fu told us, first thing we're gonna do is just highlight the important information in the problem. So like I told you a second ago, important information we're looking for is like in total, per pound, like things that kind of lead us to set up an equation. One of the first pieces of information that they tell us is that she sold a total of 165 pounds in total. Total means that that's a definite amount. That's how we know this is going to be an equation, not an inequality. All right, so 165 pounds of apples and peaches. And then we know she sold apples for $1.75 per pound and peaches for $2.50 per pound. Last thing is that she made $337.50. So we want to know how many pounds of peaches did she sell. So the first thing that we are going to do is define our variable. They're talking about two things in this problem. They're talking about apples and peaches. To make it easy for ourselves, let's use A for apple. A is for apple, like I told Aiden. And P for peaches. So we defined our variable because that's what we're trying to solve for. And that's what we don't know and what we're trying to solve for. The next thing that we need to do is to try to write two equations. So we're trying to relate these things, right? So they're talking about two things. They're talking about the total amount of pounds, and they're also talking about the total amount of money. The total amount of pounds is 165. So we know that we're going to write an equation that says equals 165. In addition, they told us the total amount that she made is $337.50. $337.50. We know that she sold 165 pounds, and we don't know exactly how much of each, but we do know it was peaches and apples. So total means to add. So peaches plus apples equals 165. And then we want to know the total amount of money. Sorry, so we know her total amount of money was $337.50. And that was made selling peaches and apples. So one apple is $1.75 a pound. So that is 1.75 right? $1.75 per apple and $2.50 per peach. And that's it. We have a system. I'm going to highlight this because this is our, or box it, I should say. So here is our system. And when you solve that system, you're going to be able to decide how many pounds of peaches and apples she sold. So now what you're going to do, you're going to take a second, check your work. Check your work. That's the only way if your answers do not look like mine, you can't get full credit on your rubric. That's what it means to get a 4. Okay, question number 2. The local deli charges a fee for delivery. On Monday, they delivered 2 dozen bagels to an office at a total cost of $8. On Tuesday, 3 dozen bagels were delivered at a total cost of $11. Write a system of equations that can be used to find the cost of a dozen bagels, B, if the delivery fee is F. So let's see, what should we do? Let's go to our steps. First thing we got to do is highlight. So it says highlight the important information in the problem. That's going to help us. So like I told you, important information is, what is this problem even talking about? Well, they're talking about delivering bagels and how much money they're making. So 2 dozen bagels were delivered for a total cost of $8. 3 dozen bagels were delivered for a total cost of $11. And we need to find the cost of a dozen bagels. So we highlighted that important information. Next is to define variables. But like we told you before, if the variables are already in the problem that they tell you to use, you don't necessarily have to define them, but these are the variables you have to use. So B means a dozen bagels, and F is for fee. So now, so the very next thing that we want to do is write the 2 equations. We're trying to relate what we know, right? So there's 2 things that we know already. We know how much it costs for a dozen bagels to be delivered. Sorry, 2 dozen bagels to be delivered. So 2 dozen bagels, right? 2 dozen bagels to be delivered was a total cost of $8. But remember, there's a fee. They charge a fee for delivery. So 2 dozen bagels plus the fee brings you to the total of $8. And then we have 3 dozen bagels plus the fee delivered for a total cost of $11. So these things are related to how much it costs on Monday and how much it costs on Tuesday. But here we have it. This is our system. All right, take a second, get that down. All right, next question. The school that Stefan goes to is selling tickets for a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior tickets and 2 child tickets. Write a system of equations to represent the price of a senior ticket and a child ticket, right? So first things first, we're highlighting the important information. So we know that information is important when it relates to the problem of selling tickets. So we know the first day, the school sold 3 senior citizen tickets and 1 child ticket, and altogether that cost $38. The second day was $52, 3 senior citizen tickets and 2 child tickets. And now we write a system. So the first system looks like the following. So the first thing that we're going to do is just define our variables. We're looking for senior tickets and child tickets, right? So senior starts with an S, so let's just use S for senior. and C for child. 3 senior citizen tickets were sold on the first day. So now we need to figure out how to relate these inequalities. So one inequality is talking about the first day, and the second inequality is talking about the second day. So on the first day, they sold a total of $38. And on the second day, they sold a total of $52. And so the total on the first day was 3 senior citizen tickets. So that's 3 times the amount of 1 senior citizen ticket, so 3S. And a child ticket, just 1 child ticket, we could do 1C or just C, equals $38. And on the second day, they sold 3 senior tickets again and 2 child tickets. And that was $52. If you have that, pat yourself on the back. You just did another system. All right. Now we are moving on to our second set of questions that come from part 2 of Ms. Fu's mini lesson. So these are systems of linear inequality word problems, similar to systems of equations, but instead of an equal sign, you're going to have greater than, less than, greater than or equal to, or less than or equal to. Question 1. Katie is buying plants and soil for her garden. The soil costs $4 per bag and the plants cost $10 each. She wants to buy at least 5 plants. She cannot spend more than $100. Write a system of linear inequalities to model the situation. So with systems of inequalities, you just need to be careful about the signs that you're using. So if you've seen in the video with Ms. Fu, she went over very beautifully how to figure out which sign or symbol to use, whether it's less than, greater than, equal to. If you're still a little bit confused, either rewatch that clip or you can use our handy helper. I'm going to pause for 1 second from this, and I just want to show you what the handy helper looks like. So this is our handy helper, and specifically over here in this bolded burgundy section, you're going to see more keywords that tell you which symbol to use. So pay close attention to that if you're still not sure. So we need to highlight the important information. So as we said, important information that kind of have keywords. So for example, the soil that she's buying costs $4 per bag. We know this problem is about soil and plants, so let's highlight information about the price of them. So soil is $4 a bag and plants cost $10. She wants to buy at least 5 plants. At least is the key word. Remember, at least means that she could buy 4. Sorry, I lied. She could not buy 4. That was definitely a mistake. At least means she can buy 5 plants or more. So if she could buy 6, 10, 100, at least just means that number or more. And then the second part says she cannot spend more than $100. That means that there's no way that, like, she has $100 in her pocket. There's no way that she can walk out if this total comes up to even 101. So at least we said means that you're either that the number has to be 5 or higher, right? When we say at least, what we're trying to tell you is that she can buy 5 plants, or if she wants to, she could buy 6 plants, 10 plants, 8 plants. Doesn't matter, but at least 5 plants means that she wants to buy 5 plants or more. So at least means greater than or equal to, which is this symbol. And she can't spend more than 100 means that she's comfortable spending $99. She's comfortable spending $50, but there's no way she could spend even $100 and 1 penny. Like it has to be $100 or less. So we want less than $100. So write a system of linear inequalities to model this situation. So we highlighted the important information. next thing we need to do is define the variables. So this question is asking us about plants and soil. So why not? Again, I'm gonna keep it super basic. P for plant and S for soil. Lastly, we need to create our inequalities. So we know that she's trying to buy plants. So we know that she can only spend up to $100. And then we know that she's buying soil and plants. So soil costs $4 a bag, and plants cost $10 each. And now we just need to figure out which symbol goes in between. So again, we said she can't spend more than $100, right? So if she can't spend more than $100, that means that this total amount has to be less than or equal to 100. And the very second thing that they're telling us is that she needs to buy at least 5 plants. We said plants was P, and she wants to buy at least 5 plants. So she wants plants, and she wants at least 5. That's the total. And now just to put the symbol in the middle, we said at least 5 means that she could have 5 or more. This one was kind of tricky because in the second inequality, there was only one variable. So even when I did this at first, I got stumped for a second. I was just like, wait. But no, sometimes in these inequalities, you're just going to have one variable in there for that second line. And this question is going to require just a little bit more work. It says, the drama club is running a lemonade stand to raise money for its production. A local grocery store donated cans of lemonade and bottles of water. Cans of lemonade sell for $2 each, and bottles of water sell for $1.50 each. The club needs to raise at least $500 to cover the cost of renting costumes. The students can accept a maximum of 360 cans and bottles. Write a system of linear inequalities that can be used to represent the situation. All right, so there's 2 parts to this problem. If you couldn't tell, that's okay. I'm gonna just make it more obvious. So it says, write a system of inequalities that can be used to represent the situation. So let's do this. We're highlighting the important information first. They have a lemonade stand. They're selling lemonade and bottles of water. Cans of lemonade are $2 each, and bottles of water are $1.50 each. They want to raise at least $500 to cover the cost, and they can accept a maximum of 360 cans and bottles. The next thing is to define our variables. So our variables, what we're talking about in this question are cans and B for bottle. If you chose different variables, that's okay. You could have chose L for lemonade and W for water. You could have chose X and Y. It doesn't really matter. As long as your inequality looks similar to mine, that's okay. So we need to figure out what we're trying to relate in this inequality. All right, so we know 2 pieces of information that's going to help us. Is that we know the amount, the most amount of cans and bottles that they can accept. They're willing to accept. I'll just write it like this. They're willing to accept a certain amount, and we know that amount is 360. And then we also know how much money they need. So they need at least $500. So what we need to do is kind of relate the rest of the information. They need $500, and that money has to come from selling lemonade bottles as well as, lemonade cans and water bottles. So we know lemonade cans are $2 each. And then they also are selling water for $1.50 each. So at least, when we see that word at least, we're saying that amount or more. So 500 or more. So 500 or greater. Then the second thing, part of the problem, is that the cans and bottles all together, when we sell them, they can't accept any more than that. So if somebody gave them 361, that's not okay, right? So that when you hear maximum, you're thinking that's the very most. So this is the system that they asked for. The second part of the question asked us if the club sells 144 cans of lemonade, what's the least amount of bottles of water that must be sold to rent the cost of costumes or to cover the cost of renting costumes? So now we need to use this information to substitute it into our inequality. So we know from our inequality 2 times $2 for each bottle of lemonade. Sorry, $2 for each can of lemonade. And they sold 144 cans. So 2 times 144. And we know that that amount, we're trying plus 1.5 or $1.50 per can. That amount, we want it to be at least, right, $500. So when you multiply 2 times 144, you get 288. Do it on your calculator. I don't know this in my head. I literally did this just now on my calculator. All right. So 288 plus 1.5C is less than or equal to $500. And now you kind of solve it as usual. Subtract 288 on one side, on each side rather. And you're left with 1.5C is greater than or equal to, boop, 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 use your calculator, 212. And now we want to divide 1.5C by 1.5 and C and 212 by 1.5. And when you do this on your calculator, oops, did I make a mistake? I definitely made a mistake the whole time. Guys, this is terrible. So this whole time I didn't even realize I put 2C times plus 1.5C, but really this should have been AB. So let me just fix that here. Guys, I make mistakes way too often. I missed you guys. You guys could have told me, Miss James, mistake. All right, so when you do 212 divided by 1.5, you would get 141.333333, right? That number goes on forever. But we can't leave our answer like that because we're talking about bottles of water. Have you ever heard of a 0.33 bottle of water? Like, is that even a thing? No. Like, when you go to the store, you can only buy a whole number of bottles of water. Like, you can buy 1 bottle, you can buy 2 bottles, you can buy half a bottle of water. That's not a thing, right? So when we get a decimal number, that means that we have to round it up in this scenario. So the least amount of water bottles that they have to sell is, if they sold 144 cans, is 142. Alrighty, that was question 1 and 2. Make sure that you take a second to get this down. All right, so that was it for my little video. But let's say you watch this whole video and you're still stuck. You have no idea what was going on. You're like, Miss James, I totally don't get it. I'm probably even more confused than the beginning. If you are still stuck, please, let me just tell you something. Here's a little secret. This is a video. You know what that means? Rewind, fast forward, go back to the mini lesson that Miss Fu taught and rewind that back. Like, it's a video, so you have all the power. You can rewatch it as many times. You might need to watch it 3 times until you get it. That's okay. Let's say you do watch it 3 times and you still don't get it. Come to office hours. But first, before you come there, make sure you utilize our handy helpers, right? We make handy helpers for a reason. We spend a lot of time on those things just so that you guys can use that and be successful on your own. If you came to office hours, you can schedule that through Calendly, or if you still need a little bit more support, something that's not as detailed, message us through Google Chat, okay? Hope you guys enjoyed this video. Take care, be safe, you're amazing. I missed you guys. Bye.